Good afternoon, Noel. Hi, good afternoon, Kelvin. Hey, Meta, I thought I connected my headphone with my laptop, but
Yes. Okay. So last week we have already finished practical ed. Only, if I'm not mistaken, number one, A1, that is actually still pending because we don't really understand the questions. Okay, so like I said, these questions actually asking of another way of how we can do searching on a sorted array sequentially, but only different way lah, from the one that is inside the suggested. Okay, so in the sorted array list, there's a method contents. This method contains sorted array. So this is the existing method contents method where it is searching starting from index 0 up until uh, it is looping. So it will find either the entry is equals to the array with the index. Okay, I am sure both of you already know about this, how it is looped. Okay, so it will change the value of this return value, which is found. So by default, it is false.
Who's presenting?
Eh, yeah. I also forgot to record. Thank you, Noel. Okay, so this is actually the existing contents methods that it want you to modify. Okay, so another way is actually is like this. It is no much difference. Instead, you are applying compare to during for the first loop. For the loop. So you compare the entry with the array for this for this function, for the array that is currently being assessed. Okay, so after that it just return, it didn't return any variable lah, but instead it just return true or false. So this is another alternative way on how we can achieve the same purpose. Okay, Kelvin, this is your part to last time, kan? Okay, so now today I saw that Noel already finished all of the part at B. I have marked it, and then we will go through it for now. Okay, so this is correct. This is memang correct kah? Wah, exactly the same as the suggested answer. So here you do this is the function to find the smallest index, the index of the smallest value, and then after that this is to swap. Okay, so this is correct. After that, this is the insertion, iterative insertion sort. I mean the insertion sort algorithm using iterative way. So this is also correct. So this is exactly as I mean, because Noel is following the suggestions from the slide, then yeah, this is correct exactly how it is how it is like the suggestions lah. After that, so Kelvin, if you want to know, then you can also refer to Noel's answer. Is if you try later about these questions, and then the suggested you can see again in our slide, in our at B slide, chapter at B algorithm for sorting. You can find the suggestions of the algorithm. It just somehow just write like this lah. Wait, somebody is coming in. Okay, so for the iterative algorithm for selection sort, this is for the questions number three, if I am not mistaken. Sorry, questions number 5. Recursive selection sort algorithm. So it must follow this. This is iterative. Recursive is this one. Okay, so it must follow this step lah. First, we need to find as long as the index for the first number is not equal to the last, then we find the index of the smallest index of the smallest. Okay, so meaning the index of the smallest value in that array, and then after that we do swap, and then we do recursive, meaning we call itself. Okay, so for this way, you can use like whatever Noel did here, where this is the same where as the iterative just now, where we are finding the index of the smallest value in that array, and then we do the swap. But another alternative way that we can code is we can create this we can create another method just to find the smallest number, just to find the smallest, just to find the smallest index for the smallest, just to find the index for the smallest value in that array, because this is being repeated from the recursive, from the iterative here. It is the same. We need to find the smallest, the index of the smallest value. Here also we need to find the index for the smallest value. So because it is keep being using, so we can make it as another method, and then we just call that method later. And then after that, this is to swap, but if you are aware in that, that is not it, not array. In that class, actually, there are already one function.
Oh,
Yeah, they are actually here. This is in chapter 8, also in the same class lah, in the sort array.java. Actually, they are already a a method for swap. So we can just use this swap. Okay, so I want here, like I said, another alternative code. First, you make this one as one method, and then it can be reused for all of the selection sort methods. And then after that, you use the existing swap method to change this, to replace this, and then as usual do the selection sort lah. The recursive calling itself. Okay, so that is the difference lah. But Noel's way is still correct lah, but it is longer code lah, and then it is repeating. So when you want to change, when there are any changes that you need to do in here, then you need to redo into places. Okay, okay kan Kelvin, Noel, you know the
okay.
difference lah kan?
Yeah.
Okay,
I need
so
to simplify the code, right?
yeah,
Oh, okay.
and then reuse whatever methods that already exist. Kelvin, if you tried this letter, then at first, if you want to try your capability lah, because you didn't try this questions, right? So maybe you don't look at this answer first, do it yourself first, and then if you really stuck, then baru you go to here to find the answer, to check the answer either correct or not. Okay, Kelvin? Okay, so since we already finished practical add, so we will proceed to our practical 9. So this practical also, actually it should be started, it should be start next week. But since we already finished the practical add, then I think we just proceed lah to this practical 9, which is binary tree. Okay, so just now, this morning, we already cover up until, I think questions 1 until questions 3 is already covered. For the extra challenge, we will do next week. And then for these questions, number 1 until number 3, I will assign first questions 1, it is Noel. Questions 3 is Kelvin. Questions 2, I will divide because it asks you to implement the pre-order and post-order traversal. So pre-order Noel, post-order Kelvin.
Okay.
Okay, so I already create the Google Doc for it. I already name it. So you can submit your answer here lah. Okay, Kelvin and Noel?
Okay.
Okay. So hopefully you can finish on or by 4:30 lah. Okay, so oh Noel. Oh, what is A?
Oh, I just like to maintain the font only.
Oh,
Yeah.
I thought you are coding directly in this doc, Google Doc. Okay, so I'm here. So you both do first lah.
How do you count the largest and smallest?
Pardon?
How do you know which one largest, which one smallest? The
The value
yeah, the value
one gets smallest value.
that the things that the test in the client only give
Uh, you are asking about which question? 2 or 3?
three. It says
Oh,
name if the entry name. Uh, how do you know which one largest or smallest?
oh, by comparing the value in each of the sequence. Okay, wait. Actually, this one is exactly like what Noel just did in questions practical at 3 and 5. It is to find the smallest value, the index of the smallest value. Kita add the following method to chapter 9, binary search tree. Kita binary search tree. So to get smallest value, to find and return the smallest entry in the binary search tree. Okay. Hmm. Kelvin, did you already finish the questions number 2, post order?
No.
Um, because I think for this questions 3, we haven't covered. Sorry, because it is binary search tree. We only cover up until binary 3 today. So this question number 3 also we discuss next week lah, or we do next week. Only up until here lah. If like that, Noel questions 1, Kelvin questions 2. Is it okay? Noel, are you already done the pre-order?
Oh, haven't.
Or haven't?
Still in. Yeah, still in question one.
Okay lah, like that. So Kelvin, you do the questions 2 lah first. Okay, Kelvin?
Okay. The the post the post they already give, right?
Post order. Yeah, we have it in
In the sample,
in the sample lah.
the post
You,
already got in the sample.
so pre-order lagi lah.
Okay.
Sorry, yeah. I think questions number two also we haven't covered because it is also binary search tree. So we haven't covered up until binary search tree. Um, because we up on until here just now. Here. So if you want to try first, Kelvin, try lah. Okay? Try questions number two. Because this week, no worry, because this week it is scheduled for us to finish for the questions practical 8. But now we already moved to practical 9. So we are a little bit ahead. Yeah, Kelvin, where are you? Are you
Okay.
angry
Okay.
already?
No, I'm
Okay.
trying. Still trying.
Oh, oh, Baba. Sorry, because I am also not confused lah. Because the name is for me is a little bit similar. One is binary tree, one is binary search tree. So, hmm.
In this lecture, we are going to talk about binary expression trees, or you can say expression trees. Fine. See, what is an expression tree? It is basically a specific kind of binary tree which is used to represent expressions, right? Expression means, we have already discussed in the previous video 3 types of expression: infix, prefix and postfix. You can check out that video in the side button, right? An expression is composed of constants, variables and symbols, or you can say operators, right? Which are arranged in a specific format, or you can say which are arranged according to some rules, according to some grammar rules, right? See, I have written this expression here. This is what? Having variables and these are symbols, or you can say operators. These are arranged according to some grammar rules. This is what infix expression. What is prefix expression? What is postfix expression? That thing also we have discussed. Fine. Now we are going to represent this expression in the form of a tree, and that, or you can say in the form of a specific kind of binary tree, and that is known as binary expression tree. Fine. Or you can say expression tree is a representation of an expression in tree-like data structure, right? And see, this is a special kind of tree in which the leaves or the external nodes, you can say these operands x
What
as
is
an
the question 2? The image of the question 2.
Pardon?
Do you have the image of the question 2 tree?
Image?
Or is it in the lecture notes?
external nodes. All the operands like A, B, C, E, F, these are
the
called operands,
binary tree,
and these
so
would be in the
can
leaf
refer-
of the tree, in the leaf node of the tree, right? So now in the internal nodes, what you are going to store? All the symbols, so you can say all the operators.
You mean
Would be
they're
assigned.
not for the binary search tree?
yeah, but I guess I can draw it myself based on the sample code.
So do I need to check first already? Upload this question slide. I upload this slide lah.
Oh.
Okay.
Is it in the chapter? Is it in the lecture notes already? This question. Oh yeah. I see.
Yeah.
I see already.
Yeah.
The building of binary tree part.
Yeah.
In internal
But we haven't covered.
Draw, you can easily construct,
until
then plus and minus,
that
right? Plus associativity also you need to take care. The associativity of this operator is right to left. This is, sorry, left to right.
You
and
already
this is also
have the
left to
PDF
right. Now
version.
we are going to use
Oh, we
these,
already
that we need to
passed
take
it.
care.
We reached the algorithm. We reached the expression trees already.
Now see, the root would be what? You need to take care of that thing. The root would be what? See,
But that one is for binary
these operands
tree.
would,
This one is
at
binary
last means the operator which would be at the top,
okay,
at the
okay.
root of the
I
Yeah. So you are similar with me.
Yeah, binary tree.
Yeah. Binary search tree is different. It is another like it. So
Oh,
later we will cover next week.
Question 2 is not binary search tree. I think. Right. It's just the traversal. Just show the traversal only. Question 2.
Implement the pre-order and post-order traversals of binary search tree. So it says here binary
that
search
would be
tree.
evaluated at the last.
So
Yes, precedence operator
why I
from the
think
infix
it is
expression plus or this
binary-
minus, because we have 1, 2 and 3. These operators are having same precedence.
Oh,
And at
so
last
sorry.
we have this minus, because we have found a root of that part would be the right left one.
But
So
the
this is the
sample
left and this is
code
the right subtree.
about
So now
the
this minus would be the root of the tree. This minus,
the-
because while scanning from left to right, this would be the first.
Oh,
so we
the
would
sample
evaluate
code
this first.
uses
Operators are having-
the
right. So now the least, the last, right? And obviously the rule is the least
Use-
precedence operator.
uses the
we are going to
binary tree code, the pre-order traverse in the binary tree. Oh.
the last in this infix expression, right? So
Let
what
me-
you need to take care of, find out the least precedence operator from here while constructing
they are
the expression
different.
tree from the infix expression, right? So now the least precedence operator is plus and
The binary
minus, but here we
search
have
is different.
plus and multiple times
It's
plus and minus.
different.
So now also you need to find out which you are going to evaluate at the
Yeah.
last, this plus or this
If I'm
minus,
not mistaken, it used or it has different
because we have 1, 2 and 3.
way.
These operators are having same precedence. Now check out the associativity. Associativity is left to right
Okay.
for this plus and minus. Now
I
scan
just
this
did-
from left to
I
right,
just did
right?
for the-
And at last we have
in the-
this minus,
for
because
the
while scanning from left to
binary
right, this would be the
tree
first, so we would
only,
evaluate this
not
first.
binary search
Then we would evaluate this plus, then we would evaluate this minus. Means this would be evaluated in the last.
So
this
you
minus,
already did
right?
lah
It means
for the
we have
pre-order.
found a root of that.
The pre-order traverse. I just referenced the binary tree. The binary tree algorithm. There's one for the pre-order.
So now this
traverse,
minus would be the
I
root of
just
the tree,
referenced it.
right? So now
And
this
then
part would be the
made one
right
for the-
part of this tree, or you can say the right subtree
there's
of
one for the post-order traverse. I
this
just
tree,
referenced
and this
it, then
complete
make
would be the
one
left
for
one.
the
So this is the
post-
left and this is the right
pre-order
subtree,
traverse.
right? Now we have broken this infix expression. Now we have two sub infix expressions. One is this one is this one. So you can now we will construct first of all the left subtree, then the right subtree. You can construct
The
right.
change not so big,
subtree,
like
subtree.
it's
Now
moving.
again apply the same rule
lines
here
on-
also. Find out the operator which is having minimum precedence. That would be the root,
Can
right? From
you
where we are going to split this
tell
expression, right?
which
Now here also
part?
plus. Plus is having least precedence, but which plus we are going to evaluate in the last. That would be the root for this subtree, for the left subtree. So now
it
scanning
is
from left to right, the
already
associativity is left to right. So while scanning, this would be evaluated first. After that, this one. So it means this plus would be evaluated at the last in this
Google Doc.
subtree in this
Oh, I
expression.
just-
So this
oh,
would be the
yeah,
root from here. We are going to split this. Fine. So
This one-
this k would be the right subtree, and this is
Once
what you can say
the pre-order, the post
this
order
complete
is
expression
in
would be
the
left subtree, part of left subtree.
sample code already.
And here the root is what? Plus 1.
So I
Now
just
this is the subtree. Now again
the
check left hand,
pre-order.
right
I
subtree. Here we
just
have operand,
changed.
so this is the leaf
I
node. So
just
no need to
changed
bother about this
something
thing. Now we will
the
construct this left subtree for this expression. Same rule. We are going to follow, find out the operation which is having least precedence. That is
the
plus.
one
We have only
here,
one plus, so obviously this would be evaluated first. After
Wait.
that we will evaluate this divide. So this is the last one which is going to be evaluated. Now split this expression, right? Part of this is, would be C, and this is the left subtree, that is A asterisk B,
I made
and
some
the divide would be the root for this subtree, right? Now here we have reached till the operand, so this is the leaf node. Now check out this one. Here we have only one operator, so no need to check out any precedence. Simply split it from here, asterisk, and the left would be A and right would be B. So we are done up to this. Now for this one, check out the precedence of the operator, both are having same precedence, associated with left to right. Now this would be the last we are going to evaluate, asterisk, right? Now here we will split it from here, so this would be the right subtree, and E divided by F would be the left subtree for this one. So here the root for this is asterisk for this subtree. Now this is the leaf node. We have reached to the operand. Now E divided by F. Here we have only one operator. No need to check out any precedence. Simply the root. This would be from here we are going to split this. So E would be to the left and F would be the right child for this one. So here we have defined. Now check out this one. Here also we have only one operator, so no need to check out any precedence. So the right child would be Y, the left child would be X. So here we have asterisk. Now for this infix expression, this is the expression tree. So we haven't converted it into postfix, and we have constructed a expression tree. Now you can easily find out the prefix and postfix for this infix. How?
the top one is the
See, find out the pre-order
post order.
oh,
and post-order traversal, right?
yeah,
For this
yeah,
tree.
I
The
But the
pre-order
one
traversal of this tree would give you
pre-order. I
prefix
just changed a
expression
bit.
for this infix, and the
So
post-order
the
traversal of this tree would
of
give you the postfix expression for this infix expression.
pre-order.
Fine. So now I guess how
I
to
just need
find out the
pre-order
pre-order,
instead.
post-order, and in-order traversal of a tree. That thing we have already discussed. You can check out that video. Here I'm going to write
So post
down here the pre-order and post-order.
it
Fine.
must
If you want to
be
compare your answer, if you
from
want to tell your
left
answer, then you can
first
construct,
and
then you can
then
find out the in-order
right,
traversal of this tree. And if
and
the in-order
then
is same as the
below.
given infix, then you can say this is the right
For
tree
the
you have, right binary tree you have constructed.
pre-order,
Fine. So in
it
pre-order,
must
how we are going to find
be
root,
not,
left, and right.
sorry, root,
Post-order means
left
here you will
and
write
right. So
left.
we see.
I need to double check if my answer correct or not.
Yeah. So have you run this?
Huh? What?
Have
Yeah,
you tested?
yeah, I run it already. Let me see.
Uh,
A B D E F G. Yeah, correct.
correct. Kayak ngam lah tu. Because then here,
It's just the ordering of the things only. But
Yeah.
the question asks for a different category, different file lah. So
yeah.
yeah.
So we make some comment here lah. This is for binary,
Binary tree, ADT one.
for binary. So next week we will cover the binary search tree.
Okay. Binary search tree looks harder.
Yeah, because it is, if I'm not mistaken, we need to do searching.
Yeah.
Okay, so stay tuned. We are a little bit, our practical is ahead already. Ahead from the schedule. Okay. So Kelvin, because we still have time for 1 hour, I think it's better if you also try questions number 1 lah.
Oh, okay.
Yeah, because you don't have anything to do, right? So it's better if you try questions number 1 also.
Oh, this one also based on this one. Oh, same as my answer. I think the answer should be the one I posted on the second question. Okay. Wait, wait. The sample code already give the example for already give the test for the binary tree, isn't it? Binary tree. They give the thing that shows.
I think maybe this one still not lah, because this it asks you to create a program. It is actually receiving postfix expression, like in the expression that we have learned previously. Either it is something like, where is the expression? The mathematical expression, the one that the
Oh,
last we covered.
mathematical instead of the alphabet.
Yeah.
Okay.
Yeah, maybe you can just the program that receives something like this or something like this, but it is asking for postfix. So postfix something like this.
Postfix math formula.
Postfix expression. So postfix expression is something like this. If you have this expression, it
Can show
can
screen.
know that eh, it is accepting a string and input in expression, and then you can write any expression that actually containing postfix expression. Postfix expression is something like this lah. At the end of that expression, there's a postfix, meaning the expression that is need to be solved first, but it is positioned at the end of that expression. So that is postfix expression. The example is like this.
Oh, okay.
So we just assume that postfix expression is a string. So just put something like A plus B or something like here lah. Here, but it will be assumed as a string. Yeah, it's okay, Noel, because there are not much hint given. I understand. I also testing the code, so we do it together. If we cannot finish it this week, then we can continue on next week. Guys, I just want to make the questions clear. Mana tahu we have different understanding. Okay, so this question is actually it want you to enter some binary expressions. For example, this one, it must receive or dummy data lah. We can just send dummy data, but it must be in expressions form lah, something like this, or something like this, or something like this. And then after that, we need to build the algorithm for this expression tree by following this algorithm evaluate. So in this algorithm, this algorithm will evaluate either the expression belongs to the first operand or second operand, or it is an operator. So what is the second or first operand and the operator? For example, this is your expression. So your first operand is A, your second operand is B, your operator is in the middle. Okay, so for example here, your first operand is this one, the sub tree. And then your second operand is this one. And then your operator is this one. And then for this one, for this type of expressions, your first operand is A, second operand is this subtree, and then this is your operator. And then for these questions, it want you to key in some expressions. For example, these expressions, and then after that, you will need to build that expression tree by following this algorithm, and then you will need to display back what is the postfix of this expression that you have entered. For example, you have entered this A multiply B plus C, and then we know that actually from this expression, the postfix one is this one, B plus C. So it want you to be able to read, to display which part is the postfix expression. So that's why it says here, use a stack to binary subtree. Use a stack of binary subtree to store the sub expression. So write your client program. So you will need to create another class for a client that access or that use this binary tree. And then you will need to display the postfix form of that expression. Okay, clear? So I know it is a little bit complicated because the only algorithm that we have here is this. So you will need to think on how you will code this. And then after that, if it needs the postfix, so usually the second operand lah if it is postfix. But it doesn't matter because the question may ask for postfix, the question may ask for prefix. As long as you can code this, and then you already can know what is the first, what is the second, and what is the operator. And then if it asks for the prefix, then you need to display the first operand. If it asks for postfix, then you need to display the second operand. Clear?
Yeah.
I think so. Yeah.
Okay, so actually I am also evaluating the code, the suggested code, but I think the suggested code have some error lah. So I also need time to fix what is the problem with the app, with the suggested code. So together we do these questions. If we cannot
I think
finish,
I tried to do it, but when I entered the things, I get error.
yeah, that's why. Here the suggested code, when we enter the expression, any expressions, it didn't accept any expressions, they will cause error. So that's why that I will need to debug that first lah.
Oh, right now,
Oh,
I'm trying to do only like put in the something like this.
are you sharing your screen?
Uh, yeah,
Present.
I share a bit. Okay. Based on the sample, I just like I just show the formula and then they just fill in, enter the ABC only, the operand. I don't let them put in.
Can you please zoom it in?
Zoom in. Right now got error. I don't know. Yeah, this like I show the formula.
Show the formula and then
And then I want them to enter the algebra, and then it should show the should show properly. Should show like the C. I enter what A, enter what B, enter what lah, and then in order. But right now I do it shows OC.
okay. So actually, it should, for example, your formula here kan, it should display back A plus B lah, because that is the postfix. So your goal letter, you need to make sure your code, because I cannot see it properly.
Oh, now to zoom in.
Yeah, that one cannot be zoomed. Only the output windows
Yeah.
can be. So, but your goal letter, you need to make sure that whatever formula that you entered, it can be classified as first operand and second operand, and then operator, and then after that, it must display back the postfix or the prefix, whatever the question asks lah. But in our case, for questions 9, it's asking for postfix form. So from your example, you key in C multiply A plus B. So and then we know that actually the postfix is A plus B. So maybe later you can display the postfix expression is A plus B, something like that. So that is our goal lah for next week. How about Noel? You code until where?
Error.
Oh, miss, can I follow like Kelvin?
You follow like Kelvin?
Oh yeah, just insert the A, the B, the C.
I haven't tested for the operand. Haven't done for the operand yet. Mine like this. Mine just only this. It shows the formula. You just enter the C is what, A is what, and then B is what. But I still got error. I don't know what I did wrong. I put the operands at the roots, and then the C and the numbers at the what do you call that? The branch there. Yeah. And then my output not so correct. My output show this 2222. I don't know why.
It's okay. We have time until next week. My code is too complicated already.
Ah,
Okay, Noel. So yeah, I don't actually really care how do you code it, as long as you are using the you are following this algorithm, and we use the step 3 or the code that we have, the method that is inside the binary tree, because there are some, the method inside the binary tree all can be used to code the expressions, this expression tree. It's just that we need to um, follow this algorithm, but and then implementing optimally the methods inside the inside the binary tree, and then to come out with postfix, or in here it is second operand. I also debugging my the code, and then Kelvin also still ongoing, and then Noel is already too complicated. But does it have some output, Noel?
Haven't.
Haven't. Oh, still, but you are following this algorithm lah. Are you following this
The
algorithm,
one
or
that algorithm is for calculating only, right? Just
calculating? This
yeah,
is
calculate.
this is like it is evaluating either the the expressions is in the first operand or second operand, if I'm not mistaken lah. To determining either the expression is this or this or this.
ah, presenting a bit.
Eh, okay.
What first operand, second operand? I can show them.
Pardon?
What's the first operand, second operand mean again?
So this is what I told you guys just now lah about this.
Yeah, I try to put my expression on the root there, but it's not working properly.
Hmm. So Beta, Noel questions just now isn't this for only for calculations?
Yeah,
For what calculations?
like if how to say, like 1 plus 2, right? Then this method is return 3. They want not like that.
My interpretation is actually this code is to determine either the expression that you entered. For example, you entered like this, and then it will determine which is first operand, which is second operand. So the first operand is actually A here, and then the second operand is like this. This is for this case lah, for this example. So it will determine which is first operand, which is second operand, and then which is the operator. So for example, we enter this expression. This is the operator, the multiply. The first operand is the A, and then the second operand is B plus C. So if we successfully code this, and then successfully determine what is the first operand, what is the second operand, and then what is the operator, then we will know which is actually the postfix. For example, here the postfix for this expression is B plus C, which is the second operand. So we just need to display the second operand after we build the expressions tree for that expression. Okay, so actually this can understand?
Means like split the expression.
Yeah. You need to split the expressions. Either it is first operand or second operand, or either it is the operator.
Oh,
And then after
okay.
that, you display back what is the postfix. So like I said just now, the postfix for this operand is this, B plus C, because it is the first expressions that we need to calculate first, but it is at the end of the expression.
So how would this postfix be written? Is it BC plus or something?
B plus C lah.
Or no, I mean the full postfix. Would it be written?
Um, just display back the B plus C, because, for example, in this case, this expression lah, right? You mean?
Mm-hmm.
So how to determine, how to display back the postfix? Is that what you
How
mean?
do you display the postfix for this formula? Yeah.
Just display B plus C. I mean, just display this apalah, this character B plus.
Display back B plus C.
Pardon?
Not sure what you mean by display back B plus C.
This display back this string lah. B plus C. This character. Just display it back.
Oh, okay.
Yeah, because if we do our expressions tree correctly, the code, if we successfully code based on this, and then we are successfully determine what is the first operand, what is the second operand, and then what is the operator, we can just display this second operand, which is actually in this case for this expression B plus C, to determine that the B plus C is actually the postfix. The postfix. I think that it is what it means by your program should display the postfix form.
Can I show mine a bit?
Okay.
Like this, yeah. Is it?
Wait, I cannot see. Can you? So can you run it again, because I need to see the process from the beginning, from the start.
I just write this, enter C. Just any number can I just yeah, like this. Is it like this guy? The postfix expression like this guy?
Your formula is C multiply A plus B, right? And then after that, you need to enter the value C and enter C and C. You enter A and B.
Oh no, enter C, A and B, but all of them.
Oh,
I just put this for simplicity on. Is it like this? Should the output be like this or something?
Beta, a post order traversal visit nodes in this order. Oh, okay. So A meaning it visit A first. It visit A first, and then it visit B, and then it visit us.
Yeah.
Yeah. Okay. So then it visits C.
And then multiply them like that. Is it?
And then it visit this.
Visit the multiplication.
Yeah. Beta. Your post order, it is like beta. We use Jamboard. Is it okay if we, because if we exceed a little bit time?
Okay.
We use Jamboard.
B times.
Okay, I open the Jamboard just now. Ayah cannot copy kan. Okay, so if it visit F, it visit C, just now we isn't it A first, but then B, then plus, and then C, and then apa? This is
Oh, oops.
I am
The,
confused.
the question asks us to display the postfix form of the formula.
Yeah, yeah.
So this my wording should be different. Postfix. This should not be postfix. Like I write like this. If I write like this should display the postfix properly.
Mm,
Is it?
can you run again so that I can see the
Oops.
amendment?
Uh, so like 1, 2, 3.
Okay. So the postfix of the formula. Beta. So now one is C, two is A, C, A, B. Actually, it didn't ask you to display the value lah. It just wants you to display back the expression only.
Oh,
For example,
not ask for postfix. Not ask
yeah,
for.
it asks for the postfix, but that postfix expression is actually referring to A plus B.
Oh, huh? Only A plus B.
Yeah, because uh, um, 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 for example, C multiply A, C, I'm not, can I share my screen? I'll stop your presentation first.
Oh,
So your formula just now, C multiply A, B. So uh, if we see it in this expression, it is like this one lah, right? And so dia punya node, it should looks like this.
yeah.
But instead, it is um, here x and here is C. Here is sub C, which is here's another big frame lah, too big of my apa. Here C B. So it is first the operand must be X. First operand is C. And then here we have
Does the question want us to produce a tree or?
you need to produce the tree, and you also need to identify which part of the expression is the postfix. But what is this, Nell? Or
Or it explain how to split the expression in binary tree, but very long.
I 13 minutes.
The leaf nodes, and the least precedence operator would be at the top, because this at the root, you can say at the root, the least precedence operator would be at the root node of the tree, because this would be evaluated at the last, right? In this lecture, we are going to talk about binary
Okay, so
expression
because it
trees,
is
or you can
13
say
minutes
expression trees.
expression,
Fine. See, what is an expression tree? It is basically
I
a
want to
process.
ask the Noel, what do you understand about this question?
Oh, they take the simple expression like a plus b, right?
Mm-hmm.
And then have to get through the algorithm to display the expression in postfix form.
Mm.
Yeah, that's all I understand.
So what is your understanding about postfix form? What is
Uh, Actually, the postfix is in chapter 1.
postfix in
Slide
chapter?
slides
Do we have to
slide.
enter? Do we have to enter the expression? Wait, do we have, how do we enter the formula? Is it one by one like mine, or you write just directly write C A plus B?
You just macam if possible we need an input lah to be entered, but for us to enter the the text field or anything lah, but we can just use dummy data lah. We just, for example, in our main we are just passing some expressions in the object.
No need input lah.
Yeah, no need input actually. You can just use any dummy expressions that, but you can just, if you want to change, then we change it in the code lah.
Then I.
In the chapter 1, postfix.
Yeah, slide number 49.
49. Postfix expression.
So the operator is in the front.
So if the operator is in the front, then it is postfix. Binary operator appear after binary operator appear after operand. Easier to no need.
Yeah. Like.
Okay, wait.
Oh, if don't need input, then I can do like this kind. Like.
Yeah, either you use input also, it is not wrong lah. As long as we can get the input lah. Either you use dummy data, or you use the your input like just now lah. It is not wrong.
This is the output lah. After if I don't want to use input, just like just put the C everything.
Yeah, but we still need to show what expression that you have entered lah in your dummy data, and then what it is display back.
What the expression mean?
Expressions is something like this lah, and this
Oh,
the mathematical expression. This one, it is all mathematical expression. So we call to code this kind of expression, we need to do expressions tree.
Okay, then I think mine. Okay, I think mine should be sure.
Yeah, though I think the first one just now you show me, actually it is like correct already, but
Oh.
you don't need to show the value lah. You just show the expressions back, but you need to see, you need to show which part of the expression that you have entered using either dummy data or input from user, which part of the expression that is entered is actually the postfix expression. So like Noel show here, the postfix expression is something like this. The operator is at the end after the operand. So prefix expression, the operator at the front. And then in fixed expression, the operator is in the middle. So, for example,
Then is my answer in the chat box correct? If like that, I write.
so your formula is this one, and then the postfix of formula is this one. Because you are using what, you are using the post order, right? Post order traversal, right?
Yeah.
Post order traversal.
Double check on the website on the Postfix upgrade.
Then how?
Hmm?
Is there a website?
It's like a website. You write in the formula and then they show you the postfix and prefix.
Oh, is it? I actually don't know about that.
I use this one.
Oh, is there already exists an application just to determine this postfix prefix? Okay, so ngam kah? Because
I answer ngam lah.
it says ngam, then ngam lah.
Yeah, I just ask if the question asks us to do like this.
Okay, so if like that, I cannot be read.
You cannot what?
Yeah, I cannot talk. The link that you give, the GitHub one, right? You cannot.
Oh no, mine's the Raj, the Raj one, not the GitHub. Why is that?
GitHub lah, but it belongs to Raj.
Oh, it is a GitHub, but when I open it, it's just nothing much there. Just white screen.
No. Here, this is you said the Raj, right?
Yeah.
It is actually GitHub, but that project belongs to the Raj.
Oh, mine.
No.
Oh, you cannot.
Me? You can see.
Mine can use. Mine, I can use mine.
Oh, Baba, you share your screen?
Present. Window. Oh wait. Present.
Novel code. I think Taryusi internet.
Maybe the firewall block.
Yeah.
Yeah. It's like this lah. The thing, the website.
So I am really behind now, but I don't know this application to exist.
Yeah, you just type it here and then it shows the postfix and prefix here.
So if like that, then correct lah your stuff, your code.
Yeah, I can, and I also added the prefix. So my answer
So even Noel links I also cannot open because I'm using Tarius the internet. I think even Stack Overflow also cannot. Check first.
Yeah. So this is my output for the postfix and prefix. Since
So then correct. So next week you share your code.
I already posted the code in the there.
In our share.
Oh, the there.
I will check later. Yeah. How about Noel? You also want? You still working on your code lah?
Oh no, for now I listen only.
Oh, okay.
I just referenced the sample code on how to do the tree. The sample code very good, very simple to follow. I think.
Later I open first the Google Doc.
Sample code. They show the first half is only for the second part is to make the root. The first part is to make the nodes. Make things very simple to understand how to make.
Oh. So the one here, the binary tree. Oh, you are okay.
I can present, yeah.
Right. Are you presenting?
No, you. Can you present?
Oh, yeah. I'm actually looking at your practical 9 share document.
Oh.
This is the code lah, right?
This is the code. I do this based on the sample code provided. They just replace some of the things with some of the things with.
So where is the reference link?
It's in the sample code provided.
Oh.
The sample code got the binary tree driver there. To make this one, to make originally it's only the original one there got binary tree driver for Java.
Okay. So I will check this code and then answer from Noel also. We will check next week. I will check next week lah for Noel. For this one, I will check before next week lah. Okay. So if the answer, if the online calculator for this prefix and infix already confirm that is the answer, I am positively saying that this code is also correct lah. As long as we are using this binary tree, all of the methods inside this binary tree, in order to build the expression tree, and then we can come out with the postfix or prefix for the entered expressions that we entered. Okay, so we meet again lah. So I will come back, but I think this is correct lah already. And then we will check Noel code next week. And then I will also show the suggested answer, how they did it. It is just another alternative way of doing this lah. This is also another way of this question. Another way of doing it. Okay, so as we all know, in doing code, as long as you are using the method that it suggested, and then it produced the output that it asked, then it is correct already. Okay, so guys, we meet again next week, yeah?
Okay.
Okay.
Bye.
Okay, thanks.
Sorry for your time.
Oh, it's okay.
23. Okay, bye.
Okay.